Symmetry. Warm-up time. Do the following figures represent symmetry? Learning time. Symmetry comes from a Greek word meaning to measure together and is widely used in the study of geometry. Mathematically, symmetry means that one shape becomes exactly like another when you move it in some way, turn, flip, or slide. For two objects to be symmetrical, they must be the same size and shape, with one object having a different orientation from the first. There can also be symmetry in one object, such as a face. If you draw a line of symmetry down the center of your face, you can see that the left side is a mirror image of the right side. When working with symmetry, the initial image is called the pre-image, and the second image is called the image because it is the final step in the process. Just like the answer to the math problem is the final step in that process, the image is what is created when you rotate something 90 degrees or flip it about the x-axis. Not all objects have internal symmetry. If an object is not symmetrical, it is called asymmetric. Examples. Types of symmetry. Rotation. To rotate an object means to turn it around. Every rotation has a center and an angle. Translation. To translate an object means to move it without rotating or reflecting it. Every translation has a direction and a distance. Reflection. To reflect an object means to reproduce its mirror image. Every reflection has a mirror line. A reflection of an R is a backwards R. Glide reflection. A glide reflection combines a reflection with a translation along the direction of the mirror line. Glide reflections are the only type of symmetry that involve more than one step. Observe the following shapes. Draw the line of symmetry for the following figures. A line of symmetry divides a figure into mirror images. The dotted lines below are the line of symmetry. It divides the figure into two equal parts. Both the sides are symmetrical. These are called symmetrical shapes. Activity. Draw the other half to make the given picture symmetrical. Visualize the symmetrical figures. Observe the pictures. They are very beautiful. Symmetry is maintained on the left and right side of the buildings. Symmetry in geometrical shapes. Line segment. Linear symmetry possesses one line of symmetry, that is, perpendicular bisector of PQ. Point symmetry possesses point symmetry midpoint O of line segment PQ. Rotational symmetry possesses rotational symmetry of order 2 about O. Rectangle. Linear symmetry possesses two lines of symmetry. Line joins the midpoint of two parallel sides. Point symmetry possesses point symmetry with point of intersection of diagonals as the center of symmetry. Rotational symmetry possesses rotational symmetry of order 2. Rhombus. Linear symmetry possesses two lines of symmetry, that is, two diagonals of the rhombus. Point symmetry possesses point symmetry with point of intersection of diagonals as the center of symmetry. Rotational symmetry possesses rotational symmetry of order 2. Square. Linear symmetry possesses four lines of symmetry, two diagonals and two lines joining the midpoint of opposite sides. Point symmetry possesses point symmetry with point of intersection of diagonal. Rotational symmetry possesses rational symmetry of order 4. Circle. Linear symmetry possesses infinite lines of symmetry. Point symmetry possesses point symmetry about the center O. Rational symmetry possesses rotational symmetry of an infinite order. Name and draw the shape which possesses linear symmetry, but no point symmetry and rotational symmetry. An angle. Linear symmetry possesses one line of symmetry, that is, angle bisector. No point symmetry. No rotational symmetry. An isosceles triangle. Linear symmetry possesses one line of symmetry, that is, perpendicular bisector L. No point symmetry. No rotational symmetry. Semicircle. Linear symmetry possesses one line of symmetry, that is, perpendicular bisector of the diameter xy. No point symmetry. No rotational symmetry. Kite. Linear symmetry possesses one line of symmetry, that is, diagonal QS. No point symmetry. No rotational symmetry. Isosceles trapezium. Linear symmetry possesses one line of symmetry. Line XY joins the midpoint of two parallel sides. No point symmetry. No rotational symmetry. Name and draw the shape which possesses linear symmetry and rotational symmetry, but no point symmetry. Equilateral triangle. Linear symmetry possesses three lines of symmetry, that is, the three medians of the triangle. No point symmetry. Rotational symmetry possesses rotational symmetry of order 3. Name and draw the shape which does not possess linear symmetry, point symmetry and rotational symmetry. Scalene triangle. No linear symmetry. No point symmetry. No rotational symmetry. Name and draw the shape which does not possess linear symmetry but possess point symmetry and rotational symmetry. Parallelogram. Linear symmetry. No linear symmetry. Point symmetry possesses point symmetry with point of intersection of diagonals. Rotational symmetry possesses rotational symmetry of order 2. Activity. Complete all the problems. Select the right one. Which dotted line is a line of symmetry? Which dotted line is a line of symmetry? Which dotted line is a line of symmetry? Which dotted line is not a line of symmetry? Is the dotted line a line of symmetry? Is the dotted line a line of symmetry? Maths lab activity. Nowadays, children like to decorate their hands with tattoos. Many of the designs of tattoos are symmetrical. Some designs are given below. Stick some designs of your choice in your notebook.